Good afternoon, everybody. So my name is Bobak, and I'm a graduate student in the cancer biology department. And today I want to talk to you about something extremely exciting, colonoscopies. Something my dad refers to as the only thing in life worse than a root canal. So colon cancer is the second leading cause of cancer-related deaths in the United States. But if patients are caught early, if it's detected early, that survival rate is 90%. If the cancer is caught late, that's a 10% survival rate. So catching colon cancer early is critical. It's literally a matter of life or death. It's the difference between 90% survival and 10% survival. Now, the current way we detect colon cancer is by colonoscopy. So a colonoscope is a thin, flexible tube with a camera at the tip of it the gastroenterologist uses to examine the colon, identify tumors, and remove them. But there are a couple problems with colonoscopies. First, the surface area of the human colon is about the size of a tennis court, but it's not a flat surface like a tennis court. It has folds and ridges and pockets, and these are all places cancer can hide. Second, a good colonoscopy requires that the colon be purged. Now, as many of you elder individuals in the audience know, this requires the patient to drink about a gallon of salt water the night before to flush the contents of their colon. Now, understandably, a lot of patients don't do this, but when they don't do it, there's a lot of residue in the colon, and this makes it difficult for the gastroenterologist to see. So all of this to say that colonoscopies are imperfect methods for detecting colon cancer. In fact, it's been estimated that 15% of colonoscopies miss cancer. So there were 14 million colonoscopies performed last year. That translates to roughly 2.1 million missed cancer diagnoses. So my lab and part of my thesis work has focused on asking the question, are there molecular biomarkers we can use that identify patients who have a tumor in their colon? So we analyzed the genomes of patients who had colon cancer and those who didn't. And what we found was that there was a gene called BVIS whose DNA was inactivated throughout the entire colon of patients who had colon cancer. In other words, we could randomly biopsy a patient's colon. If BVIS DNA is inactivated, that tells us it's very likely there's a tumor in that patient's colon, and they need to be examined thoroughly, frequently, and carefully. This way we can ensure a 90% survival rate and not the 10% survival rate. So we think we've identified a colon cancer signature that could save lives. Thank you.